Hi, my name is Tim Kraus. I'm with the Windows Management Instrumentation Group at Microsoft. I'm going to talk to you today and give you an overview of the Windows management technologies that are being developed for Windows 2000 and the Microsoft Back Office platform, as well as the Office platforms. Our agenda today will be the definition of management in the context of administration and manageability versus management solutions. We'll discuss where Microsoft is going in terms of manageability and what we expect of our independent software vendors or ISV partners as it relates to management. We'll also talk about Windows Management Instrumentation. WMI is Microsoft's implementation of a standard developed by the Distributed Management Task Force. And we'll discuss that a little bit, and we'll describe the architecture and show you architecturally where that fits into our environment. We'll talk about other Windows management technologies as well, as an example, where the Active Directory is in context with management. How about the Microsoft Management Console? What providers are we providing to end users and to customers as well? We're also going to talk about what happened to WEBM, Web-Based Enterprise Management, which is a term that until a year ago was very common around Microsoft to describe our management technology. And we're going to talk about who should care about this and why it's interesting. In other words, we're going to tell you why you should care if you're a customer, why you should care if you're an ISV, and why you should care if you're a developer in this technology. First, let's describe management. Over the last year and a half or 2 years, what Microsoft has done in terms of our thinking about management and manageability is we've really refined our idea about management and what manageability is. We did that against the backdrop of our previous notions of administration versus management and manageability. We tend to think about administration as a task-based or transaction-based user intervention in a particular technology. As an example, adding users or groups to a Windows 2000 domain or a Windows 2000 directory, adding tables or rows or columns to a SQL server, something that requires user intervention and typically a transaction-oriented sort of event. When we think about management, we refer to process-oriented sorts of things like lights out operations or automatic backup or restore and rollback of certain transactions that might occur. Management in that regard fits in really 3 areas, and one of the areas is an infrastructure. Within an operating system environment or an operating platform environment, you have to have an infrastructure that's capable of providing that sort of manageability so that ISVs or value-added tools can plug in and actually do the real heavy lifting and do the work for your environment. There's another layer that we consider called the tools environment. Those might ship in a product. You might find them from third-party ISVs, but usually those are single-server transactional sorts of tools that we're going to ship or that we're going to have ISVs ship for us in support of our platform. And finally, there's a value-added solutions environment. That's where we've asked our ISV partners, and in some cases our hardware vendor partners, to really think about cross-platform and cross-discipline sorts of manageability or management sorts of tasks. Microsoft is in the business of adding the infrastructure and some tools, and in one area that we'll discuss in just a little bit, we're adding the value-added solution as it relates to management and manageability. Now, across that backdrop of the various layers of the architecture, there are really 7 disciplines of management that we want to talk about. First area is change and configuration management, and that's really 2 issues. The first issue in change and configuration management is the ability for you to maintain a state or to keep a desired state on a specific desktop or server. That desired state management, as we like to refer to it, is important as an example when you're trying to lock down a desktop. There are a lot of users in the world, I among them, that every now and again will blow up a DLL or screw up an executable file or remove a file that was necessary for some sort of an operation. Desired state management would be the business of understanding the state or the files that are required in that particular environment and then reloading that DLL or that executable for the user that's done something errant and blown it away. The second component of change and configuration management is to manage the configuration of large installations of software. That's a lot different than just maintaining a desired state. And the implications of that across an enterprise are pretty broad, from bandwidth implications to network availability implications to timing or dependencies as it relates to scheduling activities. So that's really a larger, higher value, more complex sort of a management task. One of the other areas that we want to look at in terms of management is event management. And event management really breaks down into the correlation and the aggregation of events, event correlation, event aggregation, root cause analysis, analysis against the events, statistical analysis against the events that are collected, and essentially being able to hand those events off to other value-added solutions, potentially in other disciplines. The third area is in the area of performance management. Performance management breaks down into two areas as well. When we look to implement an application or look to implement a specific task inside of an enterprise environment, we have to consider the implications of implementing that application across the network. So we have to be able to do some pre-deployment performance simulation. We want to be able to take a transaction, a typical transaction as defined in that application, spread it across a number of users or a simulated number of users with a simulated number of servers, and assess the impact that implementing that application is going to have on our infrastructure. We need to know where the bottlenecks are. We need to know where we have to do additional development work in order to make it a successful implementation in our environment. After the implementation, we've got post-deployment performance management. And that really can be, you can derive a baseline from the pre-deployment simulation and then use the post-deployment performance management to assess a service level or to monitor service levels against applications or availability or network traffic or network availability or routers. And in this internet intranet environment, that's particularly important, especially if your application lives outside of your environment and you're renting space, if you will, from another provider, potentially from an application service provider. You need to be able to monitor or measure whether you're getting the full value for the dollar you're spending in that application environment. So the post-deployment performance management or service level management area is beginning to increase in not only complexity but also importance in a lot of our enterprise environments. Another area that we talk about are problem management, and that's typically a help desk application. And a help desk application, as an example, sees the events that happen in the event management space, looks at the correlation that occurs, and then dispatches the right resource or the right set of assets over to where the problem might exist. And the important part about problem management is that you look across these management disciplines not only as technologies, but also as business processes. So problem management becomes more and more complex when you talk about Tim Kraus's laptop, as an example, being down, or a printer being down, or a print server being down. But more importantly, an SAP server being down, or a printer that's associated with the SAP invoicing module that may be important to the bottom line revenue of a particular company. So problem management is growing in importance as we look across the complexities of the enterprise in distributed architectures. Storage management is important, and there are two aspects of that. The first is the traditional hierarchical storage management and backup sorts of activities, where you might take something that's very valuable data and put it on a much cheaper storage mechanism like a streaming tape drive or something of the nature, so that you can collect that stuff without throwing additional dollars or resources at a disk farm, as an example. But the second aspect of storage management that's important in a distributed environment, because of the nature of the distribution and not having all the servers potentially co-located in one environment, is the dynamic storage manageability. In order to be able to determine in the context of a business process, what if my ERP application can't commit this transaction to a disk? The reason that's important is because that storage mechanism may create dependencies across other applications that occur in batch jobs. And so it's incredibly important to be able to deal with the storage ability or the management of storage in an enterprise environment in the business context. The security management area is two areas as well. The first area is the implementation of a firewall or some security that holds users out that aren't allowed to see your resources. You want to give people access to certain information in your internet environments. You need a firewall to be able to allow them that access. The second access, or the second aspect of security management, is the ability to assign users and groups inside of your environment specific permissions to access resources that exist in your environment today. The last one, but certainly not the least, and I've learned over the last couple of years of working in this space, particularly in the program group, some very interesting statistics as it relates to batch output and scheduling. In an enterprise environment, as an example, roughly 73% of the scheduling or of the processing that takes place in an enterprise environment, particularly a cross-platform enterprise environment, takes place in a batch environment. The reason for that has been that applications in different application distributed environments or host-based environments haven't heretofore been able to talk and been able to exchange data in a very common or very free way. As a result of that, you have to batch up huge sets of these activities. And as you might imagine, the dependencies that are created in those batch processes are incredible. For instance, when you close SAP for the evening, there are requirements that certain files exist and that certain outputs have executed properly through the day in order to get to the point where you can close out your ledger, if you will, in an ERP module. So there are incredible amounts of dependencies that are built in batch jobs. The scheduling mechanism is the thing that monitors or controls all of that dependencies and all of that output as it goes across the enterprise. Now, those 7 disciplines have to also work across 3 domains. And the domains that we like to talk about are the desktop domain, and obviously Microsoft has an incredible investment in the desktop area. The server host environment, which becomes incredibly important when we talk about distributed architectures, Unix, Microsoft Windows NT, and moving forward Windows 2000 and products after Windows 2000, and the network environment. And the network might be things like static devices like routers or bridges or hubs or gateways or intelligence devices that sit on top of a network. Typically those domains use different sorts of techniques and different sorts of protocols, if you will, to be able to manage the 7 disciplines across those 3 domains. So when we take a look at the entire picture, that is management and manageability, what Microsoft has had to do over the past 3 or 4 years and in our development of our platforms moving forward is to include an infrastructure that's adequate to be able to deal with the solutions that will manage those particular disciplines over several different domains. Now, why is this tough? Today, if you look at an enterprise environment, you have what I'm going to refer to as stovepipe technologies. You have managed entities that are incredibly different technologies. As an example, a network router might be very different from a printer, obviously very different from an operating system or a desktop, and certainly different than an application. Each one of those specific devices has a specific API or protocol associated with it that surfaces or forwards information. So you might have a printer, as an example, that has a very specific application that manages the print function. Or you might have a router that uses something like SNMP in order to forward information about its health. Certainly our operating system environment uses Win32 and the COM environment, COM and DCOM environments, in order to be able to implement some of our eventing or some of our alerting mechanisms. And other applications that are even hosted in our environment, as an example, may have specific APIs that are proprietary, specific logs, specific event mechanisms that will allow you to mine for that data. So as you take a look at this particular architecture, traditionally, the hardest business has been to mine for the data in all of these stovepipe technologies. What that's led people to do, essentially, is to build a framework where they have specific drivers that mine data across those specific environments. The next layer up, the next layer of abstraction is the object definition. After you mine for data in those very complex environments, and sometimes very diverse environments, the next thing is, how are you going to store that data? In what object reference or what object model are you going to place that event so that you can extract value out of that data that you've gotten? All of that has heretofore been fed into a proprietary framework or set of APIs and protocols that are used by a management solution to extract information, place it in a proprietary data model, and then that framework or that application, management application heretofore, has extracted specific value out of that data. The challenge with that is the lack of ability to associate business processes across those technology silos. So you have specific technology silos that exist, but you can't necessarily associate that printer with that routing device with that business process that may be an ERP or customer relationship management type of an application. It's made it very difficult to manage the business process and to prioritize the right assets and resources when things go down. So what is WMI? Windows Management Instrumentation is our implementation of a set of standards that's being developed by the Distributed Management Task Force around eventing models, around an object mechanism or an object model that allows you to, in a common way, surface the information or look at the information out of various technology stovepipes or various technology silos, so that you don't necessarily have to understand DMI and SNMP and BAPIs and Win32 APIs, but all of those mechanisms forward their management information in one common object model. The goal of that is to allow the higher value solutions, the vendors that offer, the ISVs that offer management solutions, to be able to use that data across a number of disciplines and potentially across a number of domains. So that common access to management information comes from all of the elements on the network that can be managed, line of business application, management applications, and managed elements, to, and it's a bidirectional issue. You have to extract the data in this common format, and then you also have to be able to replace data and make activity against that data to go down to the managed element, to managed applications and managed elements. So you actually have to have a bidirectional flow of information. Now, the reason that ISVs, and there are lots of ISVs and IHVs that are looking at WMI or WebM specifically, the SIM implementation, and we'll talk a lot about SIM and what that looks like in some of the architectures. But the reason this adds value to ISVs and IHVs is because heretofore, each one of those hardware vendors had to write a specific driver for one of those technology silos. What this allows them to do is to get out of the infrastructure business. It allows them to add value to their customers by taking what may be a commodity platform and surfacing information. Where the old paradigm was a framework vendor sitting on top of that managed element and mining for data and extracting those managed elements, this gives the vendor the opportunity to differentiate themselves in the marketplace, to surface that data to one common object model so that management ISVs can extract that data and do interesting things with the data and associate those in a business process or add value to the enterprise. So it's got a lot of appeal to a lot of different aspects of the marketplace. More importantly, it's a common instrumentation model. Now we're beginning to reduce the complexity of these managed environments. We're creating a common way for these things to surface data and a common way to extract the data, so that, and it's standardized across several different platforms and across several different management sort of implementations, so that hardware, network elements, line of business applications, and even processes can be modeled in a common way, and management ISVs can pick that stuff up. The advantage to them, obviously, is they get out of the infrastructure business. Customers love the notion that they get an opportunity to manage their business as opposed to managing their technology. More important now for operations managers than ever before, because the expectation is that an operation manager will contribute to the top line in terms of revenue gains, and I'll give you some examples of where we see that happening today, as opposed to just being a cost center and managing a technology base. So, what does a WMI architecture for management look like inside of the Windows environment? If you take a look at it from the bottom up, there is the core services, which are instrumentation or infrastructure. Microsoft's investing very significant resources in building this instrumentation. Frankly, in Windows 2000, we're not there yet, because the object definition, in order to create this standard, we have to have the consensus of a lot of partners and a lot of ISVs and IHVs. Microsoft is working really hard in the standards organizations with those IHVs and ISVs in order to be able to define that object model and what those core enabling technologies look like. We will ship in our platform in the Windows 2000 timeframe core management services that are available. But those services are available for customers today in Windows NT 4 SP4, in Windows 98, and in Windows 95 with service packs and OEM releases. So you can add those infrastructural components today in the platforms that we have today, and as we move forward, to make that data available to operations managers. This technology, in terms of the instrumentation, while not being all complete yet or all inclusive yet, is available today for customers to be able to take advantage of simplifying their architecture and their technology. The second aspect of that are the built-in functions, and we're going to have some of those as an example. To do scripting appropriately in Windows, we're including things like a Windows scripting host, and that's got a lot of momentum in the industry. There are a lot of people that are writing specific scripting interfaces to that scripting host, And that will go a long way to helping ISVs and customers in simplifying their architecture. You also have to have the value-added solutions that sit on top of the architecture. And as you might imagine, those are very, very important to produce the advanced management solutions or to do the interesting things with the data that are surfaced. Microsoft is in the process of managing Windows and our Windows environment as best we can. ISVs are important to this architecture because they will be in the business of looking across platforms and across management technologies or across managed element technologies. That's an area that Microsoft's not going to get involved with. We want to make sure that the Windows environment and our back office environment is the most manageable in the marketplace today. The architecture is a typical COM architecture. You have a management application that sits on top. It produces something called a provider. A provider is either a DLL or potentially an executable that the IHV or ISV write, and it's a subscriber publish paradigm, so that this provider sits in this thing called the Win management service. And when an event is surfaced, that provider subscribes to those particular events, extracts those events, and sends them to the management application or to the managed element that's interested in subscribing to those events. So if you take a look at the architecture, the requirement is to have a repository, that is a metadata, some object definition. Microsoft took a look at several opportunities or several different types of object models, and we even had the opportunity to build our own. Instead, what we chose to do is to go with an industry standard mechanism called the CIM, the Common Information Model. And that Common Information Model today is being refined and worked on by several standards bodies across the industry. And in fact, that repository is the basis, the object model or the object repository, that is the basis for WMI today and moving forward. So let's take a look at what WMI looks like. You've got DMI and SNMP and other driver level types of data that are available that would typically require their own APIs and protocols to surface events. You've also got things like Win32 events, and that might include the registry and the event log and the perfmon and some of those things that people are familiar with mining for data out of in the Windows NT environment. Management applications write to ACOM/DCOM, depending upon whether it's a centralized or distributed environment. And these management applications essentially subscribe to the Win management service or the WMI agent that lives inside of that object manager. And that's essentially the common schema that we've been referring to, or the unified schema that we've been referring to. In addition to that, non-Windows managers can also extract that information because it is in a common format. They can extract that information because the Win management service provides access through XML over HTTP. There are other technologies that are involved in this management technology picture. Let's talk from the bottom up to make sure that we understand them. The first level are the providers or the mechanisms that will get managed. That requires some driver level piece of code that allows people to be able to publish and subscribe to the Win management service. So you see all of those providers and all of those managed elements plugging into this thing called the Win management service, or the WMI infrastructure, if you will. Key to that is the ability to register resources in the Active Directory. Clearly you've got events that are being surfaced about managed elements, but the managed elements or the managed business processes and the managed applications and the managed devices have to be registered inside of the Active Directory so that the work of WMI, and one of the key tasks of the CIM model, is association of those technologies to a business process. Now you're no longer working specifically at a server, but you're looking at an SAP server that specifically gets priority above potentially Tim Kraus's laptop when he's on the road, or an intranet router that may be interesting to some people, may not be interesting to everybody, but the company's top line and potentially bottom line get affected when that business process called ERP fails or the invoices can't be printed. So you need to be able to associate that technology with a business process. We can do those associations with the object model we find in WMI, and we can also associate those business processes with the resources that we find in the Active Directory. Both of those are key components to the management story or the management strategy moving forward. Overarching all of that is the Microsoft Management Console, or the MMC user interface. The MMC is very, very important for a Microsoft-only environment, and we really encourage people to write MMC snap-ins and to produce their UI in that so that other sorts of snap-ins can be brought into that environment and that you can look at a broader scope of technologies or processes. We also know that ISVs, as an example, are going to write their own branded interfaces. We encourage ISVs to also write their own branded interfaces because they potentially are going to manage different domains than a Windows environment might be involved in. And they also might manage cross-platform, where the MMC is not necessarily appropriate, or there might be situations where the MMC wouldn't be appropriate across, as an example, a host-based environment or a Unix environment, where a branded interface might be appropriate as well. All of these management technologies are important to helping a customer understand more about their business process and more about their enterprise environment. And this helps to define, for the ISVs that want to add value and want to help move Microsoft technology into the enterprise, these management technologies help to define a direction of where Microsoft is going and how they can plug in and add value to the technology as we move forward. WMI has some features very briefly. The Win Management Service, formerly the SIMOM, is a host process. It is essentially a service that runs natively in the operating system that allows for the subscription and the publishing of those events that are surfaced from managed elements, including applications and business processes. Most interesting hardware components have been exposed as SIM objects. So if you take a look at the Common Information Model, what you'll see is an application model, a database model, a networking model, a devices and systems model. There are other models as well that allow you to extend the Common Information Model, and therefore, by extending the Common Information Model, feed information that may be interesting to management ISVs about your particular technology or implementation. You also have event support. You know, the event support that we have today in Windows 2000 is the ability to surface events, to subscribe to those events, and to publish those events across the disciplines and across the domains. That allows ISVs to pick them up. Anybody that writes a provider to WMI can subscribe to those events and essentially do interesting things with the data. But you see now the paradigm is changing pretty dramatically. As opposed to a framework actually going into the technology and mining for specific data and extracting that data and holding it in a proprietary object format, what WMI allows these people to do is to get out of the business of mining for data. And it allows the hardware vendors and the ISVs and the business process vendors to differentiate themselves by automatically surfacing this data in an industry standard way so they are manageable out of the box. That doesn't mean that they provide management, but that those business processes or those hardware elements are manageable out of the box to an industry standard where an ISV who understands that standard can pick the data up and do interesting things with the data. Common Information Model is hierarchical. Very briefly, I'll describe what that means. There are classes, properties, and instances. A class is an object, as an example, that's defined in the Common Information Model. And one might be, as an example, storage devices. Well, as you can imagine, there are lots of different storage devices. Gosh, there's physical disks, CD-ROMs, tape drives, storage silos that you might have in an enterprise environment. And each one of those is a specific subclass inside of this thing called storage devices. Now, if you take a look specifically at the physical disk aspect of that class, or that subclass of elements, if you will, that has some very specific attributes or properties that need to be managed. As an example, heads, cylinders, sectors per track. There are lots of things that you have to know specifically about a physical disk that you wouldn't have to know necessarily about a tape drive or a storage silo. Now, every one of those physical disk characteristics can be defined by an ISV or an IHV down to a specific type of implementation. And this gives them an opportunity to extend the Common Information Model to include things that might differentiate them from their competitors. An example might be Seagate hard disks, and they may include the manufacturer and the model number, which are not necessarily included in the common information model. And so Seagate hard disks have manufacturers, or the manufacturer and the model number in their properties as it associates that associate their specific managed element. More importantly than that, Seagate may have 10 or 12 different types of hard disks. So the instances of that implementation across those types of classes or subclasses, inheriting those properties through the specific instances of their implementation, make this a very, very, very powerful model. Give you the ability to work from the bottom up to define a specific class of data, a specific property against that class, and specific instances. Inheritances can be derived from the top down, and data then can be pushed from the bottom up. Again, it's a metadata, which is data to describe data, and it's a very complex and powerful way of doing business. Key to that is the ability to have in the properties and instances an association with a business process. What used to happen as an example, in SNMP model, is that you knew a device by device ID had a problem, and you could then go to that device and do work against that device. Key to this model in the properties and instances and the ability to inherit properties through the class architecture is that now you can associate that device with a business process, and it becomes more meaningful to the operations manager, to the data center manager, when he's looking across management of his implementation. He can prioritize fewer resources more effectively. He can automate responses to certain resources that are not as important necessarily as those that may need high touch or high visibility sorts of management. So it gives him a lot of flexibility in terms of how he chooses to prioritize his tasks or to deals with events or manage or problems that may arise in his environment. We currently are working with a SIM v2.x namespace in the Distributed Management Task Force. There are 340 classes and 1,600 properties associated with the core schema. We have work groups that are currently looking to extend that core schema in areas like devices and systems, in the networks environment, in the database area, systems environment, and applications environment. Microsoft has people in a lot of those working groups doing good technical work with ISVs or IHVs that are interested in each one of those extensions to the model to help define what that management looks like. And it's incumbent upon Microsoft to be able to consume that information and hand it to the subscribers or the management application that subscribe to that data. So we've got a big responsibility to understand that model and to know where it's going and to help to influence that how that works, along with a lot of the other IHVs and ISVs. SIM deployment is, in a broad architecture, SIM deployment is generic and could describe anything. It could describe a business process, a workflow process, a discrete manufacturing process, an eventing technology. It could describe dependencies. There are a lot of things that the SIM architecture could describe. And so we encourage people to understand how to extend that common model, to extend it or to represent things that are important to them from a business perspective. And we really want to help people to distinguish classes and instances, not just events and not just specific hierarchical or top-level classes. Microsoft is going to ship and build, as an example, WMI providers. There are several WMI providers that were built, some of them by the WMI team, Windows 32 provider, an SNMP provider that maps SNMP events into the common information model, a registry provider, an NT event log provider, performance monitor. There's an Active Directory provider to monitor the health of the Active Directory. We also have some device-level drivers and some other sorts of providers that are coming on as well. Other teams at Microsoft, similarly, have built providers that enable their particular application or their particular technology to be used quite well in a WMI environment. Systems Management Server, HealthMon, NetMon, DHCP, SNA Server, Office 2000, DMI. We have a DMI mapper that was built with Intel that we're going to ship in our environment, and that helps those legacy pieces of hardware platforms, as we move into the future, map directly into this new object model or this new architecture. one of the key areas, and I think this is a representation of how valuable a provider can be, and I'll take the example of MS Info. Very, very simple provider, but as many of you know, if the help desk person comes to your desk and asks you what your implementation is, and I'm guilty of this like anybody else, the end user is probably the last person to ask in terms of what's your configuration and what's on your machine. So the folks at our services and support organization, those folks needed a way to interrogate the system and pass the information back to the PSS provider to allow him to see the configuration on the machine and to allow him to understand the applications and where there might be DLL conflicts, and he can balance that configuration against a knowledge base of configuration so that he might understand where some of the problems might reside. Very simple to do. A function of writing a provider that subscribes to the configuration data on each one of the end user machines. That data gets extracted by the service support of the help desk people essentially, and those people can balance that configuration against a knowledge base of configurations. That functionality, just the MS Info functionality, has actually served to reduce the amount of time on a PSS call, to increase the effectiveness of the PSS support people, and has allowed us a tremendous cost saving in terms of people going to desktop, or help desk employees going to desktops and actually touching the desktop, because there are some things they can talk the employee through over the phone without walking to another building or going to another area of the building and actually touching the desktop. So this has been just the use of a very simple implementation of WMI has gained for us a pretty significant cost savings in our help desk operations here at Microsoft. There are also partners shipping WMI-capable agents on our CD, and I've listed those for you here: BMC Software's Patrol, Computer Associates Real-World Interface, CompuWare Ecoscope, Hewlett-Packard's ManageX, Intel as the DMI provider that we provided or that we built with them, and we're going to ship that on the technology as well. The NetIQ App Manager implementation, formerly Platinum Technologies ProVision, now CA, since the CA acquisition of Platinum. Formerly Siemens Nixdorf TransView agent, which is now a CA agent because the Siemens Nixdorf TransView business was purchased by CA. And also a Tivoli Enterprise agent. So there are lots of opportunities to do heterogeneous management in this environment, and we're working very closely with some of the top ISVs and the top thought leaders in the industry to make sure that our system is not only manageable, that's the infrastructure, but also to provide them with management solutions that they may already have in their enterprise. And these are certainly among those that are market leaders and thought leaders and very popular in the industry today in different aspects or different regions. There are also other people that are working very actively with the WMI project team who and in some cases, didn't ship agents on the CD because potentially of development cycles that couldn't be synchronized or whatever. Among those are Blue Curve. Compact's Insight Manager, as an example, is an element manager, surfaces data in WMI as a way of differentiating Compact from other hardware vendors. Dell also does that with the Open Manage platform that they have, and they now surface information in WMI. Hewlett-Packard, not only in ManageX, but also in Top Tools and the ITA implementation that's coming from those folks. That's a WMI implementation. Intel's working hard, as an example, to instrument the motherboards that they OEM to some of the more popular vendors that's already WMI instrumented, so that if somebody wanted to look at the health of a PC, they already have the instrumentation available on their motherboard. They get the opportunity, and I know this is valuable for me, as an example. If my fan stops, I'd like someone to be able to alert the help desk if I have a very large server, like an intranet server, like MSN, as an example, might need for their data center operators to know that a fan stopped so that they could cut over some of the traffic on those internet lines to other sorts of backup servers or other sorts of mirror servers while they solve the problem proactively, as opposed to waiting for hundreds of thousands of users not to be able to log on to MSN, as an example. So the instrumentation of the hardware by Intel is working to help us and all of our vendors become more proactive with the way we manage our environments as well. Network Associates, from a security perspective, Seagate Software, very common storage management solution in our environment, and Tidal Software that does a lot of batch output and scheduling and is a very good cross-platform solution for batch output and scheduling. So here's what WMI and our management technology promise. This is the net. It gives us the opportunity to have common access across data, common access to data across platforms. Incredibly important. We don't want to place operations managers and customers in a position to have an additional skill set in their data center to manage Windows differently than they might have the skill set to manage Unix or potentially their host-based environment. So WMI gives them a common instrumentation platform in order to represent that data in a common way. Now, some implementations are going to be native WMI implementations. We're delighted about that, obviously. There will be other services that are services we're going to call a proxy service, where, as an example, the WMI data may exist, and a provider may extract the WMI data out of the Win management service, change it into an object manager for an enterprise management solution, and forward that data to a manager of manager or host-based environment type of a management implementation. We think that's particularly important when you consider that changing management solutions can be incredibly painful, and you want to be able to implement the technology that you're introducing in the marketplace with the management technology that you have today. So in conjunction with our ISVs, we're also producing, or they're producing with our help, proxy implementation so that they can use their current management architecture or infrastructure to manage our technology as they implement it more in their enterprise environments. And we're certainly encouraging them to implement it more in their environments. The goal overall of WMI is to reduce stovepipes, to simplify the environment, to reduce the number of proprietary or unique interfaces that have to be approached when trying to manage an entire system. And it allows customers to integrate management applications. As an example, wouldn't it be interesting if you could take the pre-deployment performance data and use that as a baseline against your service level manager? Wouldn't it be interesting if your business process could surface an event like, yes, in fact, this ERP posting or updating happened today, so that your scheduling processor would know that it's okay to close the books at the end of the day or to run the invoices at the end of the day. So there's the ability to pass information between the event management architectures that exist, or the help desk architectures, or the batch output and scheduling architectures, or the performance management architectures. Becomes increasingly valuable as we move down the road. And for ISVs, that's particularly important because it means it places smaller ISVs on a more level playing field with a common infrastructure. And that's particularly important as we look for a broader range of ISVs that can manage our platform or that can host our platform in their environments. And that's very important. So, what happened to WebM? Web-based enterprise management. The Distributed Management Task Force took on WebM as an initiative in June of 1998. Microsoft is a member of the Distributed Management Task Force at various levels, and we'll describe that very briefly. To the Distributed Management Task Force, that is that standards body that describes the common information model, WebM has several components. There are actually 5 that I'll talk about. One of them is the common information model. That's that common data object repository that we've been speaking about. There's another one that's the access to the data across platforms. You want to be able to take your information from WMI, which is a Windows implementation of WebM, and share it with somebody else's implementation on a Unix platform, as an example, and consume that Unix information into WMI so that your management environment can look across both of those environments. You may have an ERP implementation on your Unix environment that has to interact with your customer relations management solution in your NT environment. So you want to be able to share those events and those problem management data across platforms using HTTP, and HTTP is ubiquitous in the industry today. We also have, as an example, a method of getting different implementations across to one another. We use XML. The DMTF has defined XML SIM as the transport encoding mechanism, and there are specifications available for you to take a look at how you, if you're writing your own object model to extend the common information model, how you would use XML SIM in order to be able to do that cross-platform. Now, key to all of that is the ability to discover elements and processes and applications that exist in the environment today. So you have to have a common mechanism for discovering those events across platforms, across disciplines, across domains, in an ability or in an attempt to try to unify how the objects are presented to the information model. Discovery is key. And last but not least, the directory area, because you want some place where you can register those events. You can register resources. You can register those users or groups in the environment, and you can associate those users and groups to the infrastructural components that will allow you to look at business processes. And now you know that if Tim, who is in finance, if Tim's desktop goes down, it's probably more important than my desktop going down, and again, I can associate the right resources to solving the problem. As I mentioned before, Microsoft is involved with the DMTF at a lot of different levels. You can see very clearly that we're involved at the board, we're involved in the technical development committees, we're represented on the marketing committee. There are also several working groups that Microsoft participates in. The App Measurement Working Group, chaired by Hewlett-Packard, the Services Working Group, chaired by Gartner. We actually chair the Systems and Devices Organization, the Applications Working Group, chaired by Tivoli. There's also a networking working group, or a networking and just directory-enabled networking working group that Cisco chairs. BMC chairs the database environment. We're keenly interested in the work that's going on there. The user working group and also the support working group. The DMTF also has partnerships with other organizations like the IETF or the Customer Support Consortium or the Open Group, who takes our standards and uses them in their implementations in a lot of respects. So, who cares about this? Customers care about this, and customers should care about this to simplify their environment today. It ships with all of our platforms in a retrofit for Win98, Win95, Windows NT 4 from Windows or from Service Pack 4 forward, and also for Windows 2000. Today we're in Beta 3 and RC1, and as we move forward into the implementation or the release to manufacture of Windows 2000. It gives customers a criteria against which to evaluate management platforms. If their management platform that they're considering for a specific discipline isn't using the WebM or the Common Information Model, they should think about the advantages that the Common Information Model would give them in terms of associating business processes and allowing them to manage their environments in a different way. And the advantages that that object model will give them are significant as we look to add value to the top and bottom line of a operational manager or support organization. Also, standards bodies care about them. And I mentioned some of those. DMTF, Open Management Group, the IT Systems Management Forum over in Europe is very keen about the Common Information Model, WebM, our implementation, WMI, and others' implementations across platforms as well. ISVs certainly care about this, and they care about it for several reasons. They understand that the paradigm shift is happening. Hardware vendors, device vendors, application vendors, enabling technology vendors are surfacing this data in this common format as a way of differentiating their technology in the marketplace, as opposed to having to go down and mine for data inside of their architecture and their platform. So it gets the ISV out of the infrastructure business, which is key. They don't make money building instrumentation. ISVs make money adding value. So to the extent that Microsoft builds instrumentation in a common way into their operating system, ISVs are absolutely delighted. It allows them also to differentiate themselves in the marketplace by adding value to various areas and in different ways. IHV loves it because it gives them an opportunity to surface this management data in a common, very inexpensive way for them. It also helps them to differentiate themselves in the marketplace. Analysts love this. You read a lot about what SNMP was supposed to do in the early days in terms of the cross-platform manageability. And SNMP was a great protocol to do the management that we've done heretofore. But as this architecture shifts in the world today, as enterprise architecture shifts from a host-based environment to more and more of a distributed architecture across several locations or several disparate geographies, analysts understand very clearly the requirement to associate those technologies with business practices or business processes. That's not being driven by Microsoft or by other people in this industry that are IHVs and ISVs. That's being driven by customers who are demanding their operations managers and their operations centers add more value to their top line, or at least don't increase the cost or increase the weight to their bottom line. So they're very, very interested in this. The analysts in the form of Meta, Hurwitz, Giga, others, have all talked about SIM and WebM and WMI implementation, addressing the data center, the server, and desktop management issues, and making it easier for customers and ISVs to add value and to find value in their enterprise environments today. So that's all I have. I wanted to mention to you that you can find information about WMI or about the Windows, specifically the Windows implementation of this technology and all of the management technologies by going to www.microsoft.com/management. You can also find information specific to the Distributed Management Task Force and its implementation of WebM by going to www.dmtf.org. There are specifications, white papers, SDKs, tutorials. There's a lot of information that will help people get a lot more familiar with this architecture as we go forward. And I appreciate your time and patience, and I hope the information was valuable to you. Thanks for watching.